to Try Ride. In Module 3, we are discussing about stochastic search in artificial intelligence. Moving to the topic. Stochastic search. Stochastic search in artificial intelligence refers to the search algorithms that incorporate randomness or probability to explore the search space. This contrasts with deterministic search, which follows a fixed set of rules. Stochastic search methods are particularly useful for tackling complex problems, especially those with noisy or incomplete information, or with where the search space is vast and finding a global optimum with a uh, certainly is a computational expensive. The compl- Here we can say stochastic search in artificial intelligence refers to a class of optimization algorithm that incorporate randomness or probability into the search process. Unlike deterministic algorithm that follows a strict set of rules, stochastic method introduce an element of change, allowing them to explore a wide range of possibilities and potentiality and escape local optima. So, such as we can say suboptimal solution that deterministic the method might get stuck in. So, in this we have like randomness, exploration, heuristic. Uh, we use for it for complex problem, avoiding local optima like that. We use for it. In here we have stochastic game in algorithms. Sorry, stochastic games in artificial intelligence. So, moving this. Stochastic games in artificial intelligence. With stochastic games in artificial intelligence present a sophisticated intersection of the game theory, probability, and discussion making, capturing the inherent uncertainty found in real world interactions. Unlike deterministic games, where outcomes are predictable based on the actions taken, stochastic the games introduce a randomness, allowing AI to navigate the unpredictable environments, where through the dice rolls or random events, stochastic games enable AI systems to handle the uncertainty of while making decisions. Generally, such as stochastic games in artificial intelligence, refers to a type of game theory where the game states transitions are probabilistic, meaning the outcome of the action is not always certain. Think it has multiplayer game, and that involves not just a strategy, but also an element of change, like rolling a dice or drawing a cards. So it has a main characters of multiple players, states, action, probability, and rewards like that. So Infinity Horizons, so most often we know that we why they are important in AI. Like we use them into modeling real world scenarios. Many real world interaction, especially in the multi-agent system, involves both strategic discussion and uncertain outcomes. Like example includes like robots, economically network routing, reinforcement learning. Uh, Stochastic games are powerful frameworks in AI for analyzing and developing an intelligence agents that can make a strategic decisions and learn to behave and optimally in environment where the outcomes are always certain and multiple agents are interacting. What are stochastic games? So here same the code. A stochastic game is a multi-agent game where the player take turns making the decisions, influencing the game's current state and the future state. Unlike deterministic games, randomness is involved in determining transactions between states and making decision making more complex. Usually we discuss now only. So it is a powerful framework in AI for analyzing and developing, right? Intelligence agent can make a strategic decisions and learn behavior optimal in environment. Learn to be behave in a optimally in the environment where the outcome is not certain or multiple agents can be interacted with that. So we use the some important concept like model building, real world scenarios, and growing robotics and economics and network routing and even to reinforce learning. So it performs some set of characteristics like multiple player states and actions and probabilistic transitions. Okay, rewards infinite horizons like that. So for the first, we have a set of state as represent the possible configuration of the game. So a set of action we have that is a decision available to the each player. So transaction probabilities, random events, the distance how the game moves from one side to another side. Reward functions, the playoff that each player receives based on the actions and the current state. Discount factory, a value indicating that importance of future rewards with the smaller values, placing more than emphasis on the shortest term outcomes. So here we come from a set of states that's like represents the possible configurations of the game, right? So simple explanation like this for this. So the think a states has all the different situations or positions that game can be in. Okay, so let's take an example. In a game of chess, each unique argument of the piece, like pieces on the board in a state, like that same in a card game, the current card in a hand and the table defines a state, right? So it's like a snapshot of the game at any given moment, like that. So a set of action, the discussion available to each player, right? So a simple explanation about it is these all are the moves or choose that player can make when the or in particular state. If you are playing checker, an action might be move this piece to two squares diagonally and the negotiations. An action might be making this offer. Transaction probability, random events like dice roll, that dictates how the game moves in the one state or another state. So this is the where stochastic parts come into the after player choose the actions. The game does not necessarily go to a fixed next state. So instead of is there a chance, a chance it will be go a several different states which having a specific probability. Like imagine a rolling a dice, you take an action to roll but the outcome which the number of numbers comes up, right? So if the random is randomly picked, so determining the next state of your game. Reward function, the play of the each player receives based on the actions and current state, right? So this defines the what good or bad for each player. When a player takes an action in certain states, they get a reward and or incur a cost that the goal of each player is typically to be maximize the total reward of the outcomes. So a chance of probability of a number like a point or money. So discount factor. So a value indicates the importance of the future rewards with the smaller value placing more empathize, right? So short-term outcomes we can say. So which we can say the factor of gamma like between 1 and 0. It used to calculate the total value of the reward over a long period. Okay. So if gamma is close to one, player can care equally about the immediately rewards and the reward for the future. They are far-sighted. If the gamma is close to zero, player can mostly about the immediate rewards and less about the what happened for the down the line. They are short-sighted. So it helps to balance the trade-off between the given getting quick win now, aiming for a large playoff later, especially in the game that can be doing independently. So here we have roles of the stochastic games in artificial intelligence. So we have modeling multi-agent systems, and we have incorporating uncertainty and sequential decision making and reinforcement learning. So, for stochastic gameplay, an essential role in AI several reasons because of the model multi-agent system incorporating uncertainty, sequential decision making, and reinforcement learning. Right? So, let's come to the model building multi-agent system. So, many of AI systems involve multiple agents that need to interact, the cooperate, or compete with each other. Stochastic games provide a framework for modeling such interaction, incorporating with both competitive and collaborative elements. So, in cooperative uncertainty, like in real world environment, are often to unpredictable stochastic games that allow AI to handle like uncertainty by making the decisions that consider both known factors such as opponent's action by sensing or guessing, and the unknown factors such as random events can generate like that. So sequential decision making. So mainly AI applications requires agent to make the decision over time, right? So, with future states influenced by the current state, stochastic games are perfect for the modeling such environment, as the requires an agent to think strategically and future outcomes. Reinforcement learning. We all know about the some about the reinforcement learning. So in this reinforcement learning, stochastic games are closely related to the reinforcement learning RL. So we can say that the subfield of AI where the agents can learn the optimal strategy through trials and errors dynamically environment. In fact, one of the key framework for RL is based on the Markov decision process (MDPS). So which are essentially single agent stochastic games, multi-agents reinforced learning extend the ideas to environments where the multi-agents interact, the each learning the optimal strategies. So again, we have types of stochastic games. So in this we have we can say there are various types of stochastic games. Each decide the address like specific kind of the multi-agent interaction. So zero to some stochastic games and general some stochastic games and a Marco Marco game. So here we can say zero of some stochastic games like in these games, one player again is exactly equal to the other player. So loss, right? This type of game often arises in a competitive situation, such as an adversarial AI security sensors, and a popular example of the maximum algorithm used in chess and other competitive games. General sum stochastic games like unlike zero sum games, the playoff in general sum games does not need to be balanced out agent can either complete or collaborate to each their objective, making those games suitable for environments where multi agents may have conflicting or complementary goals. Marco game or the special case of the stochastic games where the state translation flows the Markov properties. The future state depends on the current state and the action taken, not a previous state. It simplifies the mathematical complexity and the widely used in AI research for the modeling and decision processing and dynamical environment. So, solving the stochastic games. So, solving the stochastic games, particularly in AI, involves finding optimal strategies for all AI agents that lead to a favorable outcomes, often the described in the terms of equilibrium. One of the most well-known solution concept is Nash equilibrium. So, where no player has an incentive to the change the strategy, given the strategies of the others. So solving the stochastic games, we have the dynamic programming technique such as the value iterations and the policy iterations are used to complete optimal policies for each agency in a game. Those methods are efficiently, but not on a scale well for the large games. So reinforcement learning, algorithms like Q-learning and deep Q-learning and has been adopted to the handle multi-agent stochastic games. Those methods allow the agent to learn optimal strategy to experience, often using the large-scale neural networks to approximate the value of functions, approximate solutions in the given complex computational difficulty of the solutions. Large stochastic games exactly many AI systems rely on approximate methods such as Carlo simulations and heuristic based approaches to find the near optimal strategies. So here we have applications of games in AI. So we can say stochastic games widely used in especially, right? So in environment where the decision making under like in the setting below some applications like automation systems and financial marketing and in security systems. So automation systems, we all know that it is a robot in robot and self-driving like that. So in robot and self-driving car, decision must be made in the uncertain environment, right? For example, automation vehicles need to account for the unpredictable events like weather change or and driver's action or obstacle like that. So stochastic games allow AI to model such as uncertainly and makes more information to take decisions. So financial market, we can say stochastic games are used in financial models to simulate market conditions where the trade acts based on the incomplete information. Random factors such as market volatility, like we can say, yeah, Interest rates can change bimodality helps. AI helps to optimize the strategical rate of the financial of the markets like research the enrollments and healthcare. In healthcare, AI can stochastic use the stochastic game model to interaction between the multi agents like patients, doctor, and insurance companies, treatments, plans, and resolve the all allocations like that involve uncertainty due to the patient's response and medical conditions, making stochastic games and valuable tools to help to decision making. And security system, we can know that cyber security we have. So AI system must defend against the random and adversarial attacks. The stochastic game model helps anticipate the magnetic potential threats and uncertain dynamic environment. So conclusion: stochastic games or the stochastic games are crucially in AI for the modeling complex, uncertain environment where the randomness plays a significant role by the interacting change nodes into the game theory modules. AI systems can simulate the real world scenarios that involve the unpredictability, uh, from backgammon to autonomous systems and financial market. The explicitity mini max algorithm so allows AI to calculate the optimal strategy, which is one of the basic algorithm which is performed in our stochastic game. Such algorithm only it is. So in such stochastic environment, ensuring better decision making in this phase to uncertainty has AI continues to evaluate the importance of the stochastic games, which can be developed intelligent systems capable and handling randomness will only grow. So it is mostly used to take the choices and guess the sense of the outcome. So I hope you guys all are understand about the stochastic search algorithm and stochastic search games. And thank you for that's it for this section. Thank you all.